So I'm going to go ahead and change this back to to Pokemon.csv, which is what we did. If you want to change the name to like be all lowercase or whatever, you can. But I'm going to change this into .csv. So for the next couple of programs, for the next program, Lab 7, you're going to be reading files. Usually you're going to be reading a CSV file, comma separated value. So in idle, I've already kind of started this file reading, and we're going to review what I did, the very few small command I did last time, which is how do we open a file? I like to say something along the lines of data rather than file, but we could call it file. We could say file is equal to open, and then we say the name of the file in the string. Okay, and the name of the file that I downloaded is capital P Pokemon, Pokemon.csv. Now, for those of you who don't know, Pokemon is, I believe, the biggest the most money-making franchise in the world. I think it's largest multimedia franchises, according to Wikipedia. Highest grossing media franchises. Pokemon at the top. So it's not something to just discount because it's kids stuff. It beats out Mickey Mouse and Winnie the Pooh and Star Wars and the Disney princesses and Barbie and Harry Potter. It's a big franchise. Merchandising, gotta love it. So Pokemon is short for pocket monster, by the way. That's where the name comes from, although it is a bit of a misnomer since they are usually in balls, capsules, on your belt, and not in your pockets. Belt monsters, maybe? That just doesn't sound as good, though. So the file we're using is Pokemon.csv, okay? By default, if you don't specify how you want to open this file, it's gonna automatically assume we want to read it. And we'll see that by doing print file. Printing the file's not going to necessarily show you anything too useful, but it will confirm whether or not you managed to follow those 20 minutes of me ranting, which is that if you get this or something like this, then congrats, you were able to download the file and you put them in the same location. If you did not, take a look at this over here in idle, right? Take a look at this in idle over here and see, does this path over here, the folder that the file reading file is in, does that match where you downloaded your CSV folder to? Right? That's the first thing, that's the primary thing to double check. If you're working in VS Code and you're having issues, open it up in idle and just double check. VS Code is a bit more of a powerful editor and tries to organize some files for you in some cases, so it's going to assume that you might opened up like the folder that it's in, as opposed to an individual file. So that might require one extra step. So I would check it in VS Code. If you're using VS Code and it's not working, I would open it up in idle, just in case. Printing this.
I tried it and it created an Excel document and I saved it in there, but then it says auto save decision because the file is not stored format, and I go to idle and it just says file not path.
So how did you well, it will open up in Excel by default. I'll come up in just a sec once and go around to a few students if you're having issues. But what you need to do is you download this, and if you print this out, it'll show the name. It'll show that it automatically opened in read mode, and then the encoding, the way the text is encoded. Let me go ahead and double check and see what's going on with you. Anyone else need help? There's going to be a number of people. Yes. So let's see what's going on here. So yeah, you don't want to Excel. Yeah, the download is just yeah, by default, no, it downloads it by default. save as. So you want to put this somewhere. So you have it on your desktop. You'll fit it back over. Into save there. Now we're going to go ahead and do this. Open this up. And see if in your downloads, you can right click and say copy. And that doesn't say nothing. It says we're going to put down this file. And move it to this folder. Paste it. And now it's in there.
It still didn't.
You should. So you make sure the name's match.
It still didn't.
Bobby. It's got this, and then CC. So we have this file. So This is what takes up most of this lecture, believe it or not. Yeah, this needs to go, this needs to be in that document folder as well. Not into here. Icon, save the file, save as, then documents, and then everything else. So now, So this is, again, like I said, most of the lecture. So what you need to do in this case is, so a lot of you, about half the cases, what I'm doing is that when they're running it, you're getting a file not found exception. And this is why. Because, let me make a new Python file. Okay, I'm going to save this. And most of the time, it's not in here. It's instead, here, let me quit out of idle to show you. Okay, idle, let's open up idle. And by default, when we're working in idle for some reason, when we create a new file and we do save it, and we save it for the first time, it ends up over here in, if we look at this path, users, profa, Andrew, for me, it's going to be your username and app data, local. So this is so by default, it's going to save it where your where the Python program itself, where idle itself is saved by default. This is generally not great because you have to get into your app data folder, which is a hidden folder. So that's a bunch of extra steps. Instead, what you want to do when you save it that first time is select somewhere else to save it. Okay, like your documents folder. Now, it may have come to pass, right? Let me go ahead and open recent files, right? It may have come to pass that basically you've already, and by the way, you can know you've saved it in the wrong place, like that folder, if you look over here and it says like users, your username, and then app data, and so on and so forth, right? Basically, it's got this long stream, but it will say like something like Python 313, okay? If you've done that and you've already saved that, instead what you do is you hit File, and you hit Save As. And then this will open this dialog again, and it'll allow you to make a new copy of this file wherever you need it. So I suggest going to wherever you downloaded the folder, which will either be in your Downloads folder, or if you moved it from your Downloads folder to wherever that is. So that should answer about half the remaining questions I've got. Okay. Now, because I only have half an hour left, I do want to move on. So if you still are having issues, just follow along, and I'll try to help you out later. But just otherwise, follow along with this, okay? Okay. Because I do need to make sure that we do some actual coding. But most of trying to get this. But now you can see why I kind of have the whole thing about you got to make sure your file can read the IRMA folder, because I spend a lot of time in it in this class. And again, if you need help, email me. I'll meet with you. If I can't meet with you today for some reason, I'll meet with you after to try to help you with it, or like even tomorrow. Okay, just let me know. Okay, so now that we've got the file, there's something that I do like to do, and you'll see this in a lot of my older code. You'll sometimes see me put a comma R over here, and that just tells Python explicitly that I want to read it. But it doesn't really, if you leave it off, by default it's in read mode, okay? Now, there's 3 ways we can read the file. 3 ways. Okay, 3 very actually easy ways to do it. The first is the easiest but also the least useful, but we're going to learn it anyway. I'm just going to say text is equal to file.read. That's it. That reads. That's it. That's all. That's the first way, and also the least useful way. Print text. And you'll see what happened here is that it says squeeze text, at least in idle, it will say squeeze text 1,199 lines. And if I double click on it to expand it, which it warns me can make things slow, it says, oh, here's the file. And what it's done is that it's printed out the entire file. What happened is that what read does is that it says, I'm going to just take the entire file, all 700 plus lines of it, and store it store it as a string, and then store it in text. So we're taking the file, saving it as a string, and storing it in text. Make sense? That's what read does. Okay? And because that's what a file is, at the end of the day, for your computer, your file is just text. It's just a string. File's just string. So read just simply says, I'm going to grab it and give it to you all at once. The reason it's the least easiest because it's just a string, one thing. And it's least useful. We're going to use it the least because when it's a string like that, it's the hardest to work with. Okay? Make sense? Hardest to work with there. The next most useful way to deal with that is I'm going to comment this out. It's important that this is commented out so that we don't try to read a file that we've already read, because it's going to, when we read a file, it kind of gets to the end of it and it's going to and if you try to read again, it's going to be like, there's nothing else here to read, mate. Come on. The other way is very self-explanatory with what I write. Lines is equal to file.readLines. Okay, and again, this kind of gives you an idea of what we might be looking at. Whoops, I tried to type print, but I hit the semicolon rather than enter. Okay, print lines. So this is method number 2. And again, it squeezes the text. And if we expand it, we get something, it chugs a bit now. Let's go ahead and rather than printing it out, I'm going to do this. I'm going to print out :10. I'm going to print out a slice from 0 to 10 and hit run now. Print out a much smaller bit. And what we get is a list. We can tell it's a list because of the brackets, right? And inside the list is 10 strings, right? 0 up to, but not including index 10. So index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And inside these lists, in each of these items is a list. Sorry, it's easy. Each item in this list is a string. Here's line 1, line 2, line 3, line 4, line 5, and so on and so forth until we get to line 10. Okay? And we can... And what lines does is that it says, well, it's pretty straightforward. It takes every line of the file and stores it as a separate string, okay? And this is more useful because typically when we want to read a string, we want to read it in a way that is digestible. And usually, going line by line is the most digestible way to do it, okay? Especially in like a text file like this that's explicitly a table, right? A bunch of data. So read lines is the way to do that, okay? Now, what's nice about doing it like this now is that I could go for line in lines, and this may irritate the heck out of you because what I'm doing here is saying essentially for singular in plural. But that's really like how I like to do it. For line in lines, but it could easily be for L in lines or whatever. Print line. And you'll see that we start printing out the entire file. Although each line of the file is separated by a space, a new line. Now the reason for this is that if we remember from above, here I'll terminate this. I thought I would. Interrupt execution. Oh, it's not interrupting. How interesting. There we go. If we go back up over here, we see that when we look at each line, every line has and then ends with /n, the new line symbol, right? Because that's part of the file. Each line ends with a new line saying it's time to go to the next line, and so it captures that. So when I print each line, it prints out the new line, and then it prints out the new line that print automatically puts in. So there's ways to get around that, but that's why we're why we've done this. But doing it like this allows us to go line by line. So for instance, I could instead decide to print out the first 5 characters of every line, if I wanted to. Right? I could totally do that. So that's the second way to read a file. The third way is a heck of a lot like the second way. Okay? And you're about to see that. Okay, first way, second way. Technique number 3 is the one that I showed you last time, which is that we don't actually need a variable to hold this unless I can just do this. For line in file, print line. And then it's going to go through in the same exact way. So if we just try to iterate straight up over, so if we just try to straight up iterate over the file, it's going to go line by line. Just as if we had done, it would have the same result of as doing read lines would. Make sense? So those are 3 ways. Whether you decide to do this versus this depends on the problem but primarily taste, which way you like to do things. Okay? So now that we've got data, we can play with it. Okay? So I'm going to actually just go ahead and open up this file. By the way, in idle, you can just totally open up any text file you want, even if it's not a Python file. By default, over here it says, hey, I'm only opening up Python files, but I'm just going to hit all files and open up the Pokemon.csv so we can read it. Now, this first line, really we don't need. It's primarily for us to read. So when we actually iterate over this file, we're going to ignore it, but let's go ahead and see what this is. First off, we've got an ID over here, okay? I don't know why I have an extra ID in this, but it will be easy enough to ignore. ID is basically the number of the Pokemon. Every Pokemon kind of has a unique number, and they have a unique name. Bulbasaur, Ivysaur, Venusaur being the first 3. Form is something that was added in, I think, Generation 6? Doesn't matter. But basically some Pokemon have special forms, which is makes them super special. Now, Type 1 and Type 2. Pokemon, essentially, for those of you who don't know, Pokemon is basically rock, paper, scissors on steroids. That's basically what the appeal of the game is. Every Pokemon has 1 or 2 types that are better than some against some other types and worse against some others. For instance, the classic rock, paper, scissors for the 3 starters is grass, water, and fire. Grass beats water, water beats fire, fire beats grass. Okay, but there were a grand total of 15 in the original game, and then they added Steel and Dark and Fairy. I think, is there any other ones they added? I think that was it. Steel, Dark, Fairy. Yeah, okay, Steel, Dark, and Fairy was one. I'm always curious as to where if they added another one and I totally missed it. So there's basically it's rock, paper, scissors with 18 options. Okay. Some options are weird, like Dragon, which basically is good against everything but ice and other dragon. So, but type, it isn't just, so it gets into that whole thing. Pokemon have also have this idea of stats, right? It's an RPG, and JRPGs have stats. Attack, defense, special attack, special defense, and then speed, and then generation. Generation is the easiest to explain. Generation just simply means how old this Pokemon is in terms of when it was created. Gen 1 being the original ones from like the 90s. All right. Speed. It's a turn-based game. If you've got a higher speed, you go first. This can be useful. Attack and defense. Basically, how hard can you punch and how well can you take a punch. Special attack, special defense. How hard can you shoot an energy beam, and how well can you take a hit from an energy beam? HP, how much damage, your life total, hit points. Those are your stats for Pokemon. Okay, and we can do some analysis, and since we have numbers, we can do some analysis on these numbers. Total, by the way, is just simply the sum of all those numbers added up. Generally speaking, if you've got a high total, it's probably a good Pokemon. That's not always true. You have some Pokemon like Slacking, one of my personal favorites, who has an extremely high total, but only moves every other turn. So it's not the whole story. Every Pokemon's basically unique, and you can find a way to make anything work. Okay? So let's go ahead and find out. What we could do here is maybe find out Let's see if we can just let's start pretty simple. What we want to do here is print out the name of each Pokemon and what their total is. Okay? And this gets into a lot of, and this simple exercise we're going to do, or rather simple to understand exercise, because understand the objective is fairly straightforward. I just want to print out this name and this number. But this gets into a lot of what you'll be doing with CSV files. Fortunately, Python has a lot of stuff built in to make this easy for us. So what do we need to do? For every line, we need to go through every line and then get this name, this field, and this field over here. Now, fortunately, we are working what's called a CSV file, a comma-separated value. It's a table. In fact, if you double-clicked on it accidentally and opened it up in Excel, it opens it up as a table. And it knows where to put everything because it says, okay, every line is a different row, and every column, I know where a column ends by looking for a comma. That's why it's called comma-separated value. So this says, this is another column, this is a column. So it knows that this one is the ID, and even though these don't line up, because the commas tell you where a column ends, it knows Bulbasaur is the name, it knows blank is the form, grass is the type 1, poison is the type 2, because of where those commas end up. Okay, so we can use those commas. Let's go, so what I'll do first is I will go and I'm going to use method number 2. I'm going to import lines because that will enable me to do something. And then what I'm going to do is, the reason I'm going to do lines is right now I'm going to do for line in lines, and then I'm going to just do a slice over here. Why am I doing this? This lets me work over only the first 10 lines. That's a lot easier to see for our output than the entire file. Makes sense to everybody? Right? So when I'm ready to do it over the entire file, I'm just going to remove this bit. Okay? Also, there's this another reason we'll see in a second. So for every line in the file, and I'm going to adjust this one, print the line. So read the file, and then into our list, and then for every line in our list, for the first 10 lines, we're going to print out that line. And we see that it prints out those first 10 lines. Now, if I want to analyze these things, this is not one of the lines I want to analyze, right? This first line, which is the legend. So I'm going to make one more adjustment. I'm going to put a 1 here and 11 here. Okay, and then we'll see the result. 1 through 10. 1 through, no. Cooperate with me, computer, come on. 1 through 10, lines 1 through 10 there. So what I've done is that we're starting at line 2, essentially, or index 1. And the reason we did that is because we are removing the, we just don't want to read the legend. The legend is not useful for us to kind of print out. So each line has all this data in it. Now, not to kind of belabor the point, how do we get each of the individual fields? Now, if you've been reading your textbook, you might recall a very useful function here. It's one of those functions that I would definitely put on like that front page of the exam or in my notes. But it's a very special function here. Line dot split. Whoops. Type in the right place. Line dot split. Okay, line dot split. And this takes in an argument, and the argument I'm going to put in is a comma. Let's go ahead and actually clean this up a bit. Line is equal to line dot split, and then line, let's call it parts. Parts is equal to line dot split, print parts. Okay? And what does line dot split So now notice, now that we've done line dot split, let's compare this to what we have now. This. So we see that our line, that when we do split, it takes, we told it to split by comma. And what it did is that it says, I'm going to take this string and separate it out based off of where I see the commas. Let's go ahead and see a more concrete example, right? I'm just going to do this over here in idle. If I say something like, let's create this. Let's go with I like to eat tacos. Big tacos. Okay, that is my string. I like to eat big tacos. And I'm going to do s.split. If I don't put anything in, by default, it splits off of spaces, right? Now see how we went from having one string to having 1, 2, 3, 4, 5, 6 strings, right? With the spaces removed, because it says, aha, space is the delimiter, is the magic word there. Delimiter being the thing that's going to be separated. It's not actually data. It's just telling me what separates one data to the other. I could also do something along weirder, like string.split, and I could specify something like T. I like oe big acos, right? And notice the spaces are in there. The spaces are in there now. Okay. So over here, when we're doing string.split comma, we're saying, hey, the data, the commas aren't actually part of the data. That's what's separating the data. Okay. So now that we have parts that are split up, we don't actually need to print the whole thing. I can just simply do something like this. Parts. If I print out, and then I can give it an index. If I say 0, it's going to give me that ID. If I say 1, though, what's it going to give me? It's going to give me the name. Right? Makes sense? Gives me the, it's surrounded by quotations because in the file, this is surrounded by quotations. So can we clean this up a bit? I think so. Okay. Let's go ahead and extract this as an individual variable. Name, right? That's the name is equal to, so for every line, we can get the name by looking at parts 1. And then I can clean that up by using another function I really like. So there's basically 2 functions you're going to be using when you read a file. The first one and most important one is, well, two new functions, ones we haven't really used much before. The first one is split over here. The second one is, you'll see, strip. And the third one that we're going to actually use, we're going to use a third one, but you're familiar with it, and that's int, to turn things into integers. So name.strip. Now strip is useful. It says, hey, I want to get rid of something. Here I want to get rid of the quotation marks in a specific way. Print name. And you'll notice that this stripped off the beginning and trailing quotation marks. Okay, strip says, hey, I'm going to get rid of anything that's at the beginning of this string and at the end of the string that matches this, a quotation mark. Okay? So strip is pretty useful. Split, to chop things up. Strip is used to clean it up. Okay? Was it necessary? No, but it makes me happy. Okay, so now let's look at these parts again. We wanted to print out the total. So our legend was, our legend was ID name form. We want to print out total. That is 0, 1, 2, 3, 4, 5. So that's index 5. Total is equal to parts 5. And because it's an integer, we want to convert it in. We'll go ahead and convert it into an integer. Okay, part total. And we're going to go call it total. And we see that for the first 10 Pokemon, we see that they're fairly close in power for their final forms. Venusaur has 525, Charizard has 534, and Blastoise has 530. Okay, for their stats. Okay. So now, why don't we go ahead and so now we're kind of getting an idea of how we need to do IRMA now. The lab problem, which is that we need to iterate over this file, and we need to extract the XY coordinates, the latitude, longitude, or longitude, latitude rather, from it, and tell the turtle to go there. We can do that by reading line by line and then splitting that line. Now for the IRMA one, as I mentioned, because it's in a subfolder called data, you'll want to do something like data/ to access it. But other than that, that's really the only difference. Okay. Now let's go ahead and do something that I might ask on an exam. Similarly, like I give you the name of this file and I tell you like, this is what the first 10 lines look like. And then I have a big ... afterwards to kind of implicate that don't hard code this, right? I might ask something along the lines of, what is the average speed of a Pokemon, right? Right, so what is the average of a column, okay? So again, how do we compute an average? Average is computed is computed by adding up all the things and dividing by the number of things you added up. So we're going to create we're not going to be clever about this. We're going to just be very straightforward about this. We are going to say total speed. We're going to set it up even before we start solving it. We're going to say total speed is equal to 0 because we are doing a running sum, right? Total speed. Num poke for the number of Pokemon. And then, this is going to give us an issue because we're about to divide by 0, but that's not going to be too long. Our answer is going to be this: print the total speed. Sorry, actually, let's say our average speed which is our answer, is equal to the total speed of all Pokemon combined divided by the number of Pokemon we just added up. Make sense? So now what we would do on this is that we wouldn't have already had this. We would write, okay, we'd read the file however we'd want, in this case, 4-line. Rather than modifying what I have, I'm going to go ahead and comment this out, right? And I'll work with those 3 lines that I've created, right? Total speed is equal to 0, number of Pokemon, and average speed. This is how we would do this, right? Even if I was giving you a list or whatnot, this is how we do an average. The only difference is now we're going to be reading this from a file. So how do we do this? Well, we could use number 1. We'll go ahead and say, we'll do the same thing we did. Lines is equal to file.readLines. Okay, we'll read the lines and then we're going to go line by line. For line in lines. And I'm just going to do one into this. Because on an exam, this would be fine because I wouldn't give you a legend on the exam that you'd have to remember to cut off. But remember that first line is essentially not got data. It's just a legend. So I'm going to cut that off using a slice notation, saying 1 to the very last line. For every line, we need to take that line and split it up into its component parts. Parts is equal to line dot split on commas because it's a comma separated value file. And then I need to figure out which part is the speed. So I could count this way. So there's 2 ways for me to do that. Index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whoops, we're on 10, 11. So index 11. Okay, so I could just simply count out index 11. Or I could note, wait a second, this is the last one. This is the second to last one. I could use negative indexing, right? -1, -2. So, but I'll just assume that if we were on exam, we're using what we know rather than and comfortable with. So counting. So we'll say speed is equal to parts 11. And I'm also going to remember, wait a second, that is a string right now. When I'm reading a file, that's a string. So I'm going to convert that into an integer. Let's assume for the sake of argument you forgot that on an exam. That probably, on a 10-point question, that'll cost you a point. It's a minor mistake, very easy. I classify that as a minor mistake. Yes, it crashes the program, prevents it from running, but it's one of those ones that once you understand what's going on, it's super easy to correct. You say, oh, right, you can't add an integer and a string. Right, I got to convert, or a string and integer. Right, I've got to convert this into an integer. Speed. Okay. And now we do the running sum part, which is total speed is equal to total speed plus the speed we just read. And then num poke, well, we just read a Pokemon, is equal to the number of Pokemon we've already read plus 1. Make sense? And so what we do now is now we can run this, and it won't do anything because I forgot to print it out, right? Very common thing to do. But on an exam, if I'm asking you to calculate it, that'd just be fine. What we do over here is now we just simply say print average speed and we see that the average speed of a Pokemon is 69.7. All right. So I think that's a good enough place to wrap up the class. So as a reminder, Ian, you can come down. And again, we are really looking for people to do this post-interview. So if you want to do this post-interview, get some cash for basically just a half an hour of your time, please. You can come speak to Ian, come speak to, sorry.
It's okay.
What's your name?
It's okay.
Antonio.
Antonio. Come to speak to Antonio, right? Very easy way to help us out our research and get compensated for us.